Hello my dear warriors, welcome aboard to the NEET English channel. This is your Captain Shreyas here, and in today's session I'm going to give you all the inputs, all the concepts, all the formulas in my handwritten form to all of you on the topic of circular motion. And if you understand circular motion well, then you can also understand rotational motion well. So get set go, make sure you have your notes ready where you can add something, or if you want to start a chapter from fresh, great, have your blank pages ready because there are lots to fill. Keep solving, keep answering with me in the chat box, and you can also be my friend on my Instagram handle as well. So before we begin, make sure that you have smashed the like button and also hit the subscribe button. Nice to see all the lovely kids out here, all my regular students as well, and all the students who are watching it recorded. Hi Rakesh, hi Shama, Mahalakshmi, Navya. I hope you guys are doing great. Hi Tishika, hi Sandhya. Hello Chandana, hello I Singh, hi Subha, hi Selvi, Yashu, Madhumita, hello Sonu, Nivedita, Jerry, nice to see you, Revant, hi everyone. I hope you guys had your lovely dinner and all excited and all energized to start with the session. Alright, so thank you for smashing the like button and let's begin. Now, let me tell you that the way I'm going to approach this chapter is going to be very different from what you have learned. So this way of, teaching this chapter, I've seen that over the last 10 plus years has worked wonderfully because you will understand the nitty-gritties and all the concepts, and you will be able to solve any circular motion problem, after this. Okay, so let's begin. First off, let me just get it over here. If I tell you that there is a person who is going in a random path, just think of Pandu. Okay, just think of Pandu, guys. So this is Pandu, he is on his cycle. So this is Pandu on his cycle. Let's just show Pandu over here maybe. Okay, great. So look at the amazing Pandu who is riding his cycle, and Pandu is going along a path like this. Okay, this is the path which is taken by Pandu. Now, when I say this path is curved, obviously it is not 1D motion, it is a 2D motion, but it is not a projectile motion. It's some random curve. And the chapter name is, whatever the thumbnail title you have seen is circular motion. You're like, sir, why are you showing this random curve? Guess what? This random curve is also made up of small arcs. Small arcs. Each arc is a part of a big circle. And since we are studying circular motion, maybe somehow this has something to do with it. Just think about it. There is a small arc over here. If I extend that arc, maybe it becomes into a circle like this. Great. Maybe if I draw a circle over here, maybe it becomes into a circle like this. If I draw or consider an arc, and if I extend it further, maybe it becomes a circle like this. Maybe if I consider this arc and extend it into a circle, maybe it becomes a circle like this. And so on and so forth. I can draw many such circles everywhere. I'm drawing this all approximate, but I am pretty sure you get the idea. So this curved motion, can I say, is a sum or a combination of small arcs together which are part of circles. Small arcs together which are part of circles. So it's actually many circular motions together. So can I also say the motion along a curve is nothing but the sum of the motions on the arcs of circles, the different circles that we are talking about. Everybody agrees with this? Crazy, right? You would have never seen this. Now believe me, the way I'm going to approach circular motion now, you will be like mind blown, and you are going to put it up after the session is over in the comments also. Already Rocky Bhai is saying, oh my god. Hi Satya, nice to see you Vacha. Hi Chandana Umi, nice to see you over here too. Now what are these circles called, you might ask? These circles are drawn at that instant. That is why they are called as instantaneous circle. Instantaneous circles. What are they called, guys? They are called as instantaneous circles. Circles at that instant. Each of these circles have a center. This circle has a center here, this circle has a center here, this circle has a center here, then the center is here, then the center is here. The center keeps changing. These centers keeps changing. These centers are called as, simply put, centers or center of curvature. Center of what? Curvature, or you can also call it as instantaneous center. So center of curvature. Everybody with me? Sahil, Sahil Shafi, I'm very good, bacha. Hi Sandeep, I'm very good. Hi Sajwal. These are called centers of curvature of those instantaneous circles. Now because there are circles, there is obviously radius also. Circle is there, center is there, obviously radius is also there. So this line over here, which joins the center and till the any point on the circumference, that is R. So that is basically called as the radius of curvature. What is it called? Radius of curvature. Radius of curvature. Keep this in mind. So radius of curvature, center of curvature, and instantaneous circles together are closely associated for any particle going on a curved path. If everything is clear, let's proceed ahead to the next point. Now just imagine I take up some such instantaneous circle. This is some instantaneous circle with an instantaneous center of curvature, and it also has some radius of curvature. Imagine that there is a particle which is going along a curved path like this. Maybe it is going to go like that. Who knows? This is the path of that particle. At that instant, if I ask you, where is the particle's velocity? You will be like, sir, draw a tangent. Sir, draw a tangent, that's it. Exactly, that's what I'm looking for. If I show basically a tangent, guys, to this point, if I show tangent to this point, that marks the direction of the velocity. So can I also say the velocity at any instant is nothing but tangent to the path, is nothing but tangent to the path, is tangent to the path, and also the instantaneous circle, and also the what? Instantaneous circle. Instantaneous circle. Very cool about this. Great. Awesome. Thank you, Sahil. Means a lot, bacha. Hi, Priya. Extraordinary, says Rakesh. All right. Now comes the next pointer. Fine, this has velocity, and I see that this velocity is clearly perpendicular to the radius. Oh, by the way, if you are wondering, sir, these beautiful notes that you are writing, so many colors that you use, can I get them? Yes, guys, you are going to get them in the form of a PDF. So if you feel that you are lagging behind, don't worry. You can just choose to watch this video. Maybe later on you can even rewind or even download these notes from the Telegram channel. Okay, so if you feel like watching only, no issues, guys. Perfect. I'm okay with that. Okay, now going ahead, I feel there might be even some acceleration. Now you might wonder, why is there acceleration? See, guys, velocity is a vector quantity. Velocity is a vector quantity. It has both magnitude and direction. So when does a vector quantity change? If magnitude changes or direction changes. If magnitude changes or direction changes, right? So this velocity can change. The velocity can change only by these two possibilities. Number one, the magnitude. What is the magnitude? Basically the speed. The speed basically changes. Number one. Number two, imagine the direction of the motion changes. So it's pointing here, then it is pointing there, so the direction changes. In either of the cases, the velocity will change. And if velocity changes, what do you say the particle is doing? Thank you, Vamshi. Velocity is a vector, Sahil. So velocity is a vector. What does a vector quantity have? Magnitude, length, and direction, arrow mark. So if the length changes or direction changes, the velocity changes. So speed changes or direction changes, velocity changes. And any such thing in which I see that the velocity is changing, I would say it is exactly Madhumidani, Shama, Sandhya, Salvi, Satya. Very good. I would say that it is accelerating. It is accelerating. Very nice. Now you will be like, wow, it is definitely accelerating. So sir, where is the acceleration? Can you please show that to us? Definitely. Just imagine I have this velocity, and if I ask you where can the acceleration be, I'll tell you I don't know exactly where it is, but I'm not sure in what direction. I know it might be there. I don't know what's the direction. I will just randomly mark it as, maybe something like this. Observe. Maybe just like this. And you will be like, what nonsense, sir? I thought acceleration is in the direction of the velocity or opposite the velocity. How are you showing it as an angle? That doesn't make sense to me. Let me tell you in a very simple way. Imagine guys, I throw something like this. It goes like this, right? The velocity is like this. Where is the acceleration due to gravity? Where is the acceleration due to gravity? Just think about it. Acceleration due to gravity is down, na? Velocity is here, acceleration is down. Do you see an angle being made? Within the velocity and acceleration? When the particle goes like this and is coming down, velocity is there, acceleration is like this. Don't you see an angle is made again? So velocity and acceleration can definitely make some angle. Badiraju, I'll be doing some problem solving. Great. No, I'm not talking about centripetal. I am just saying there is some acceleration. Just forget circular motion for now. Circular motion is going to come in a bit. You will be like, wow, this is crazy, sir. This is news. I always used to think acceleration will be in the direction of velocity or opposite the direction of velocity. Now, today I got to know from you, because I watched this video, acceleration can make acute angle, perpendicular angle, obtuse angle, 180 degree, 0 degree. All possibilities are there. All the possibilities are there. Perfect. Now, how do I use this in circular motion, and why am I discussing all these things? Observe. Just imagine that a particle has some velocity like this. Let's say the acceleration is over here. Okay, this acceleration is over here. Won't this acceleration have two components? My dear students? Wow. You'll be like, sir, which two components? X and Y? No, not X and Y. I am saying in the direction of a velocity and perpendicular to the direction of the velocity. Crazy. Let's try this out. So I have two components of acceleration. One component of acceleration is basically in the direction of velocity. The other component of acceleration is perpendicular to the direction of the velocity. Now I'm just going to write this: acceleration in the direction of the velocity, and this component is acceleration perpendicular to the velocity. I'll be like, okay, sir, what's the significance of that? Why are we taking in the direction and perpendicular to the direction of the velocity? What is the use of this, sir? Hold on. Imagine this acceleration in the direction of velocity. Just imagine it for some time, guys. Just look at it. Okay? If I have velocity and if I have acceleration, what will happen? This velocity will increase. This acceleration will pull that length of that vector. This acceleration will change the velocity. It will increase its magnitude. Because it is accelerating, it will change the velocity. Maybe the velocity might become like this. It will stretch it. If the velocity is here and if the acceleration is here, opposite, then the velocity will reduce until it stops. So it is changing the length. Everybody? Very good. Also, just imagine if the velocity is here and we are saying the acceleration is here, that means velocity is changing here. That means it will just change the direction. It will turn that velocity, and once the acceleration is again perpendicular, again it will turn that velocity into a new direction. Crazy. So basically, the component which is perpendicular turns it. The component which is in the direction or opposite basically changes the length or magnitude. So guys, think about it carefully. This acceleration which is in the direction of the velocity, what is it responsible for? Changing the magnitude or changing the direction? Changing the magnitude or changing the direction? Obviously changing the magnitude. So this is changing the magnitude, or basically changing the magnitude, or basically the speed. Whereas this one is changing, what is it changing, guys? Changing the direction. Changing the direction, that's all. Cool. Now let's think about our instantaneous imaginary circle. We had drawn it over here, but I have deliberately not shown it here because I wanted to explain all these concepts. Now just let's draw our imaginary circle. This is your instantaneous circle. Great. Okay. And I will also show the center of it. Maybe the center is over here. I'll just show the center here. This is your radius. Okay. I'm so sorry. All the things are just, merging onto it, but I'm pretty sure you are able to see all this because of the choice of the colors. Okay, great. So this is my radius. This is my center. This is my circle. I hope you guys can see that circle as well. Now, this acceleration, which is in the direction of velocity, isn't it tangent to the circle? Isn't it tangent to the circle? So what do I call that acceleration? The acceleration which is in the direction of velocity and also tangent to this circle. What name can I think? Come on, guys. Tangential acceleration, obviously. Obviously. I'm just going to call it as nothing but the tangential acceleration. This is nothing but your tangential acceleration. Symbol A subscript T. This is along the tangent. Great. Now, there is another component, acceleration perpendicular to the velocity, which changes the direction. What name should I give? It's along the radius. It's also passing through the center. So I have two names in mind. So usually they are called as radial acceleration. It is usually called as the radial, or just because it passes through the center, centripetal acceleration. Centripetal acceleration. Symbol for that is usually AC. Symbol for that is usually AC. Radial or centripetal means the same thing. Cool. So guys, all these days, all the students who started, uniform circular motion, centripetal acceleration, then non-uniform circular motion, tangential acceleration. Stop all that. Not needed. Learn it like this. Basically, acceleration and velocity can make any angle. The component of acceleration in the direction of velocity is called tangential. Component of acceleration perpendicular to the direction of velocity is called radial or centripetal. Simple. Number two, the tangential component changes the speed. The centripetal component changes the direction. Perfect, no? Awesome. Great. Can I also say one more thing? See if you guys agree with this. The total acceleration is the centripetal acceleration plus the tangential acceleration vector wise. Yes or no, guys? Come on, put it up in the chat box. The total acceleration is centripetal plus the tangential vector component. This vector plus this vector is this vector. Or this vector can be split into two vectors, centripetal and tangential. This is vector wise, but magnitude wise, simple. A is, this is hypotenuse. These are the two sides of a right angle triangle. This is one component, this is another component. So this will be root of AC square plus AT square. AC square plus AT square. Agree, disagree, guys? Understood? Clear? Can we move ahead? Perfecto. Amazing. Thank you for the hearts. Looks like everybody is enjoying this. Looking at things like never before. Great. So we have talked about what is the concept of instantaneous circle, center of curvature, radius of curvature for any motion of curved particle, any motion of a particle along a curved path. And then we spoke about how velocity is along the tangent and how velocity can change if speed or direction changes, which is then said to accelerate the particle. And then we also went on to the concept of naming them. The one which is along the tangent is called tangential acceleration, which changes the speed. And the one which is perpendicular is called radial or centripetal, which changes the direction. As simple as that. Maybe we can solve some simple questions on this and maybe you can guys give me some idea. Okay, just imagine, guys, you are going into some mountainous terrain with your family on a vacation. Which place you want to go? I don't know. You want to go to Ooty? Let's go to Ooty. Okay, Pandu is going to Ooty. Pandu is going to Ooty. Okay, fine, on family vacation. There is a nice road. There is a nice road like this. There is a nice road like this. Beautiful road. Look at this. This is the ghat section. And there is a car going like this. Okay, on it. There is a car going like this. Ignore my drawings right now. Oh my god. So many wheels I drew. It looks like a truck. Anyways, ignore. So this is the car in which Pandu is going on a beautiful road. Thank you. Okay, feeling the physics right now. You're going to imagine it also right now. Okay. Okay, now observe this. Hello Vinod, welcome, join in. You are going to imagine some crazy things. You are going on a vacation with your family on a ghat section. Imagine the car is maintaining a constant speed of 40 kilometers per hour. 40 kilometers per hour. Constant speed. Your speedometer reading always shows 40. Doesn't change. Now you are just in the car in your back seat. You are just looking at the mountains, beautiful green lush mountains, waterfalls are there, clouds are there, it's very cold, you're eating some chocolate, you're eating some chips, and then you think about Shreyas Sir teaching physics in your favorite NEET English channel, and then you think, am I accelerating or not accelerating? Then it suddenly clicks to you that, oh, I am dash, not accelerating or accelerating. Fill in the blanks, guys. Fill in the blanks, guys. Are you guys accelerating or not accelerating? For all the students from Kashmir, guys, yes, you can imagine Gulmarg, Sonmarg, Pahalgam, whichever mountains you want to imagine. Are you accelerating or not accelerating? Fill in the blanks. Not accelerating? Okay. Kritina Laishram has told the correct answer. Anish also has told the correct answer. Very good. We are accelerating. So all the students who said we are not accelerating are wrong. What? Observe, guys. Just some time back I mentioned over here. If velocity changes because of magnitude or direction change, then you are accelerating. Is magnitude changing? No. Constant speed 40. Direction changing? Yes. Am I accelerating? Yes. So you are accelerating. You are accelerating. Correct. So guys, here the question is are you accelerating? Yes, acceleration is there. Acceleration is there because since the direction of velocity is basically changing. Basically it is changing. Now if I ask you what is the direction of the acceleration, you'll be like, okay, let me think. I'm going on a curved path like this. So my velocity will be like this. Okay. Only my direction is changing, no? So guys, think and tell me, is there going to be any kind of centripetal acceleration or tangential acceleration? Which of the two will be there? Centripetal or tangential? Speed is not changing. So tangentially there should be no acceleration. So tangential acceleration will be 0. Tangential acceleration will be 0 only because speed is constant. Remember, I just showed you that speed changes because of tangential acceleration. If it is not changing, there is no tangential acceleration. Direction changes because of centripetal acceleration. So centripetal acceleration is not 0 because direction is changing. Direction is changing, right? So my dear students, where should my acceleration be? Only centripetal will be there. And this centripetal only will be the total acceleration because there is no tangential acceleration. As simple as that. So my acceleration right now is here, or in this case it will be here. In this case it will be here. When I reach here, 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 it will be here. So, this is how the acceleration is changing from one side to the other depending on where you are turning. It's always pointing towards the center. There is no tangential acceleration, only centripetal is there. Isn't this a beautiful conceptual problem which has cleared a lot of misconceptions from your head? Now next time you are going to Ooty or Pahalgam or Sonmarg, Gulmarg, Shimla, whatever, Kodaikanal, alright, and then you are going on this in this nice ghat section, then you can tell your parents or your siblings, hey, listen, I'm accelerating. Then you will get one tight slap. What you are saying? Nonsense. Shut up and eat your chips. What you are saying? Accelerating. I'm not accelerating. I'm going at constant speed of 40 kilometers per hour. Then you show them this slide. Shreyas Sir, Captain Shreyas Sir told all this. We are accelerating. They will be like, oh really? Oh my god, my tangential is not there. Centripetal is there. Oh, thank you so much. Which channel to subscribe? Then you tell them. This is NEET English channel. You subscribe. Shreyas Sir will tell you when you are accelerating, when you are not. All these nonsense misconceptions, no, he will remove from the head. Okay? Great. Chalo. Let's move on to the next one. Let's move on to the next one, guys. Okay. And now let's talk about basically the different, terminologies that you need to learn in circular motion. Different terminologies that you need to learn in circular motion. Okay. So what are the terminologies that you are going to learn in circular motion? Starts with position. From position you go to displacement. Then after displacement you go to velocity. After velocity you go to acceleration. That's the general trend. Always start with position. Then you go to displacement. Then you go to velocity. And then you go to acceleration. You have learned all these things in 1D, 2D motion. Same things. So you have position, then displacement, velocity and acceleration. Displacement is change in position. Velocity is your displacement or change in position upon time. Acceleration is change in velocity upon time. Same things also come in circular but in a different way. They are called angular position, angular displacement, angular velocity and angular acceleration. Angle wise. Because you are going round and round, no? So why will you talk about velocity? We'll be talking about those round, arc, circular things. So angular position, angular displacement, angular velocity and angular acceleration. Symbols are slightly different, but you will see a lot of resemblance. It's very similar. So let's try to understand that. Okay, just imagine a circle. Just imagine, okay, a circle. And always we need a line which is called as the reference line. This is a reference line with respect to which you measure each and everything. You measure each and everything with respect to the reference line. This is your center of curvature. It also has some radius. Imagine somebody or something right now at some particular point over here. This angle which it makes, theta, at that instant, let's say at t, at that instant, that theta is simply called the current angular position. Angular what? Position. It is just called as your angular position. Everybody with me? Sir, is circular kinematics a scary chapter? No, I'm teaching you that only. You will understand. It is very similar. Okay, great. Next, I move from this point to some another point. I move over here. Where do I go? I move over here. So I have changed my angular position. So this new angle that I have covered is the angle which I have displaced. So that is delta theta. What is that? Delta theta. So my dear students, delta theta is nothing but my angular displacement. What is it? Angular displacement. Again, it is generally measured in radians. Usually you measure it in radians. Now, do you see I have also covered an arc over here? Do you also see I have covered some arc over here, my dear students? Some beautiful arc. So this arc, this arc that I have covered, has some length L. The length of an arc is basically radius times the angle subtended. Radius times the angle subtended. Yes or no, guys? So here, what is the length of the arc? L. What is the radius? Let's assume it as R. What is the angle subtended? That is basically delta theta. That is another relationship which you should know. Standard geometry, trigonometry, length is R delta theta. Okay? Very good. Always angle is in radians. Yes. Angle is in radians. Perfect. Now I have a brilliant question for all of you. You guys are going to be like, oh my God, really? Let's see how many of you guys can answer this. Imagine Pandu went mad. Pandu went mad. Look at this Pandu now. This is an example question. So I'm just going to show Pandu over here. So this is your Pandu. Okay. Okay, Pandu's head is on fire. Imagine this. This is Pandu on fire. Okay. He became mad after that. And what he does, he starts running around in circles. He became mad. Okay, great. Now he starts from here and comes back to the same point. He starts from this point and comes back to the same point. Pandu's head is on fire. So guys, my question to all of you is, in one complete rotation, delta theta is how much? How much is the angular displacement? How much is the angular displacement? Okay, let's see. No, Vishwajit, I haven't. What is the angular displacement? Okay, 0 or 360. Give me one answer, Anish. You cannot give options for the options. The examiner will give you options. Students have to answer. They cannot say A, B, C, D means, sir, A or B. Then examiner will not give the exam. You have to give me only one. Okay, Madhusmita saying 2 pi. Most of you saying 0. What if I blow your mind and tell you what is the answer, guys? The correct answer is 360 degree, or basically 2 pi radian. Now your head is on fire. Pandu's head calm down, but your head is on fire. You'll be like, what nonsense, sir? You are saying after I came back. No, sir. Sir, I thought displacement means final and initial position. If they are same, displacement is 0. Yes, my dear student, displacement is 0. But I'm asking you, angular displacement, angular. If I rotate like this and come, angular displacement is not 0, it is 2 pi. But yes, displacement is 0. Displacement is 0. Then I'm like, oh my God, this is crazy. Sir, what if Pandu went one round like this and then again came back like this? Then what is the angular displacement? Then it is 0. Then it is 0. So you go like this and then again come back like this. Then the angular displacement is 0. Clear? Understood? After this you will not make any mistakes. Understand the difference between displacement and angular displacement. Nobody will teach you in this much detail. They'll angular displacement, change in position, they go radian, go next to angular velocity. That's how they'll teach. No, here we are going to discuss everything in proper concepts and all. Okay, next, let's take another circle. Okay, just imagine there is a particle here at t is equal to t, and it reaches here at t plus delta t. At t plus delta t. Perfecto. Okay, so now what happens? It covers certain angle. That angle is delta theta in delta time. So covers angle delta theta in time, basically delta t. How quickly it does it? How quickly it does it gives me a new quantity called as omega, which is angular speed. So omega is nothing but angular speed, which tells me how quick is the displacement in that time interval. So basically it is angular displacement upon the time which you take, basically the time taken. Now there are two kinds of angular velocity. Number one is the average angular velocity. That tells me the total angle which is covered upon the total time taken. That is obviously expressed in radians per second, units wise. That is your average. I started my time here, and after some more time I was here. Maybe in between I accelerated, decelerated, I increase speed, decrease speed, whatever happens, that will give me the average speed. So that is the first thing which you should know. This is average. But obviously there is instantaneous at that moment. Instantaneous angular velocity will be nothing but the small time that you take, and the small angle covered, the small angle displaced. That will give you the instantaneous angular velocity, and that will be just d theta, derivative of theta with respect to time. That is your instantaneous angular velocity. Very nice. Perfecto. Curious Lingo, my Telegram channel, link is there in the description box. Just go down, click more, you will see the link for the Telegram channel. Join, you will get all the notes, everything. Perfect. Now you might be wondering, sir, is the angular velocity and velocity related? Yes, definitely. Why not? The velocity is like this, and I think omega is related. Just think. Why? Because more the angular speed, more is the velocity of the particle. So here is what I can say. Just go back one slide. L is r delta theta. So guys, we'll just use that. We know, what do we know from the previous slide? Length of the arc is basically r times delta theta. Let's divide by time. Divide both sides by delta t. So it will become L by delta t is equal to r delta theta by delta t. What is delta theta by delta t? Come on, you can see it right over here. Delta theta by delta t, my dear students, is nothing but the angular velocity. What is r? R is radius. What is length by time? This length by time. Guys, come on, think. This length divided by this length divided by the time taken, delta t, is the velocity of that particle. That is it. That is nothing but the velocity of the particle. That's it. So I think I'm just going to sit and block this. This is another formula. V is equal to r omega. Perfecto. Great. So we got so many new formulas over here. They are very easy to remember. Velocity is displacement by time, nothing else. And V is r omega, just like L is r theta, delta theta. So like that only V is r omega. Now what did I say? After position, displacement, velocity, the next term should be acceleration. So we're done with position, displacement, and also velocity. So the next obvious term should be acceleration. So again, let me show that beautiful circle. And just imagine, initially the particle was here and it had some angular velocity omega I, and after some time the particle reached here. So at that position it had some new angular velocity omega f. So when it was here, the time was t. When it reached here, the time was t plus delta t. So I would say in time delta t, the angular velocity has basically changed. Therefore it has nothing but angular acceleration, which is simply put, how much is the change in angular velocity, upon the time taken to change it, That is simply put angular wise acceleration. The symbol for angular acceleration is nothing but alpha. Just like you have A, you use alpha. That is all. So now, can you think what is the average angular velocity? Sorry, acceleration. What is the average angular acceleration formula? It will be nothing but the change. That means omega final minus omega initial upon the time taken. Can you guys also think about the units of this? Can you guys also think about the units for this? Come on, think about it. The units of the angular acceleration, radian per second. So it will just become radians per second square. Just like you have meters per second square, it has now become radians per second square. Okay. Yes, Thirulochhan ji, I have just done the relation between linear and angular velocity. Yes, that's what this one was. Similarly, you can also have instantaneous angular acceleration. That will be simply put d theta by dt, that is at that moment, small time, small angle. That will give you instantaneous angular acceleration. Fine. Now you might be wondering, just like velocity and angular velocity are related, is somehow angular acceleration related to something? Let me tell you the answer. We all know, what do we know, guys? We know velocity is r times omega. Okay. Yes. Oh, sorry. Why did I put d theta? I'm so sorry, guys. I'm so sorry. So sorry. Okay. D omega. Thank you. Yes. Sir, are you explaining lessons from starting of syllabus for NEET? Chirusni Sambangi. I am basically doing all the high weightage topics first, and then I'm going to the other things. So my full focus is right now on making sure that you guys understand high weightage things, which is going to give you marks for NEET exam as well as boards, and then we'll go to other things. Okay, I hope this is clear. Okay, we all know V is equal to R omega. Let's differentiate with respect to time. So this will become dV by dt. This will become dV by dt. This will be equal to, R is a constant, so put it outside, into d omega by dt. Perfect. Now I just want you to think, d omega by dt is alpha. That is nothing but alpha. So angular acceleration. What is dV by dt? Rate of change of speed. When does speed change? Acceleration. But which acceleration? Tangential acceleration, guys. So the answer over here should be only tangential, not centripetal or total, because this term over here is nothing but rate of change of speed. Remember, tangent only changes the speed. So rate of change of what? Speed. So that one is your tangential acceleration. So I'm going to block this one as well. Is that clear? So we got all the relationships now. Length of the arc is r into angular displacement. The velocity tangentially is r into angular velocity. And then finally, the tangential acceleration is r into alpha, angular acceleration. Everything is r alpha, r omega, r delta theta, something like that. Great. So if I just go back to one of these slides over here, finally, I think we have got the answers over here. I can just probably put it. So I can just write that tangential acceleration, maybe over, where is it? Yeah, tangential acceleration. So tangential acceleration is nothing but r into alpha. This is one important relationship. Also, using derivatives and differentiation, you can prove very easily that the centripetal acceleration which is there, is also v square by r. That is also possible to prove. So you have to remember this, but you don't have to remember the proof and all that. That's not so important. Remember the application side of it. You can also use V is r omega. You know V is r omega. So just put r omega over here, square it and divide it by r. So this will become r square into omega square divided by r. This r and one r gets cancelled. So finally, you will also get AC is nothing but omega square r. So in fact, I can just say I have two formulas for centripetal acceleration. Either use this or use that. It's completely up to you guys. It's completely up to you. V square by r, speed square by r, or angular speed square times of r. No, mass is not there. Guys, I have not included mass anywhere. That mass will come later on. Don't confuse. Okay? Only V square by r. M is not there. Or omega square r. Clear? Very nice. Awesome. Okay, great. Now let's do some questions based on whatever we have learned. So see guys, whatever we have learned, I have shown you over here only. Okay, we have talked about length and r and theta, angular velocity and the linear velocity relationship, angular acceleration and tangential acceleration relationship. Let's see if you guys can do this question. So what do we have over here? We have basically a fan, and we take the blades of the fan, maybe something like this. Okay, and I mark certain points. This is point A, this is point B. And now I ask you basically a simple question. Angular velocity of A versus angular velocity of B. What should I put over here? More than, less than, or equal to? Come on, let's see if you guys can answer this question. This is a fan, and this fan is basically rotating with some angular velocity, or you can just say it is a rotating fan. So come on, think and tell me what symbol should I put? Equal to, less than, more than. Angular velocity of point A versus angular velocity of point B. Okay, Vinod saying more than. Interesting. What about others? Everybody should spam and put it up in the chat box. Everyone. Sandhya also saying more. Acha, is it? B is greater than A. And what is the reason for that? Anish also saying more than. Shama saying opposite. A is more than B. Madhumita saying equal to. Interesting. So you guys are saying that the one which is far, or maybe you are just looking at the fan on the top, but maybe it's winters and you're not looking at the fan because it's not rotating now. So maybe you can just turn it on and see which has more angular speed. Then you will slowly realize that as the fan rotates, and this blade comes over here, this would have moved some distance, this would have moved more distance. Distance is different, but the angle is same in the same time. So actually speaking, it should be equal, guys. Because they cover equal angles in same time. Mind blown. Same angle, same time. Then you'll be like, sir, what is different then? You know what is different? It is this velocity of A versus velocity of B. Yes, that's the linear velocity. This is velocity of A. This is velocity of B, guys. Remember, A is closer, so in fact the velocity of point A will be smaller. Remember, V is equal to R omega. This is same for all of them, but the more far away it is, then this is also higher. The more far away it is, it has to travel more distance to cover the same angle. So that's why you will see B is higher, A is lower. So I'm just going to put a less than symbol over here. Is that now understood? Clear? Never will you make a mistake. Difference between velocity and angular velocity. You should be very, very clear about this. Can we move ahead to another question, which is going to come up on your screen? Okay, ready for it? Okay, let's see if you guys can do this. Just imagine this is the question. Just imagine this is the question. It says a particle going in a circular path increases its speed to, let's say, 4 meters per second in 2 seconds starting from rest. Radius being, let's say, I don't know, maybe 4 meters or anything, whatever you want to take. You can just take 4 meters. Okay. The question is, find tangential, centripetal, and let's say the total acceleration. Okay, let's try to find this out. You'll be like, okay, crazy, this is something really interesting question. The particle going in a circular path, it starts from rest, and it increases its velocity to how much? 4 meters per second. And how much time? In basically 2 seconds. In 2 seconds. So just imagine, it has moved some angle, it has increased the speed, and the radius is given to be also 4 meters. Now, what kind of accelerations will it have? Think about it. Speed is increasing, so definitely it has tangential acceleration. Direction is changing, so definitely it has centripetal acceleration. It has tangential also, it has centripetal also. Let's find out each one of them. Everybody ready? Let's do this. Tangential acceleration is basically rate of change of speed. How much has the speed changed? 4 from rest. So can I not say 4 meters per second minus 0? It went from 0 to 4. So change is 4 minus 0, final minus initial. In how much time? Think about it, 2 seconds. So hence, can I not put this as 2 meters per second square, because this was meters per second and this is second. So 2 meters per second square is the tangential acceleration, yes or no, guys? Everybody with me on this? Perfect. Let's now talk about the centripetal acceleration. Which formula can I use? V square by R. Okay, let's use that. So using V square by R, what is the velocity? It is 4. So 4 square by R. What is R? That is also 4. So 4 square by 4 will just become 4 meters per second square. Oh, I found out centripetal also. So I found out tangential. I also found out centripetal. The only job remaining now is the total acceleration. Don't you see, my dear students, the total acceleration will be this one. This will be the total acceleration. And can I not say total acceleration is root of centripetal square plus tangential square? What is the centripetal? Centripetal is 4, so I'll put 4 square over here. Tangential is nothing but 2, so 2 square. So 4 square is nothing but 16, 2 square is nothing but 4. So this will be root of 20. 20 is root because 20 is 4 into 5. So I can just write this as 4 into 5. So take 5, keep 4 outside. So root 4 is 2. So it will become 2 root 5. What is 2 root 5? Meters per second square. That should be your final answer. All the 3 things done. Understood? Clear? Amazing? Can we move ahead? Are you getting some ideas? So these are all questions on non-uniform circular motion, by the way. These are all questions on non-uniform circular motion. Okay, let's do one more simple question that will again induce some more new ideas in your head. This is another question. For a particle going in a circular path, of radius 2 meters, the angular position theta is given by example t cube minus, I don't know, something like 4t plus 2 radian. The question is find omega, then alpha, and what else you want to find? Let's also find tangential and centripetal at t is equal to 1 second. After 1 second, what is the angular speed? What is the angular acceleration? What is the tangential acceleration? What is the centripetal acceleration? Let's do this, okay? You will get very good ideas in your head. You will build a lot of concepts and you will also relate it to translation motion. See how? Theta is given, we have to find omega alpha. I just know from my previous theory over here, angular velocity is rate of change of angular position and angular acceleration is rate of change of angular velocity. Acha, so I need to use derivatives. So let's use derivatives. So angular velocity is rate of change of angular position. So it will be derivative of t cube minus 4t plus 2. I will just split it up. So it will be nothing but derivative of t cube minus 4 times derivative of time plus derivative of just 2. Now derivative of t cube, nx raised to n minus 1. So 3t square minus derivative of t with respect to t is basically 1. Derivative of a constant is just 0. So this will be nothing but 3t square minus 4 is the angular velocity. Cool. Now once this is done, let's also find alpha. So alpha we all know, guys. Alpha we all know, observe, is nothing but d omega by dt. So it should be nothing but derivative of basically 3t square minus 4, which is nothing but derivative, or I'll just put it on the other line. So which is nothing but 3 into derivative of t square, which is nothing but 2t, minus derivative of constant will be 0. Derivative of constant will be 0. T square's derivative will be 2 comes outside, t raised to 1. T raised to 1 is t. Okay, 3 2s are 6. So 6t will be alpha. Everyone fine till this point? Okay. Now let's try to find out what is the value of angular speed at 1 second. So basically at 1 second, what will you do? Put the value of time as 1. So it will become 3 into 1 square minus 4. 3 into 1 square minus 4 exactly. So what is 3 into 1? 3. 3 minus 4? Minus 1. So it will be minus 1 what? Radians per second. Minus just says that it is going the opposite direction. That's all. Alpha value, just put the value of time as 1. Just put the value of time as 1 second. So this will just become 6 into 1. So it will be 6 radians per second square. So I think I have found at least 2 answers by now. 2 answers by now. Done. Now tangential and centripetal, how are you going to find it out? Tangential and centripetal, how are you going to find it out? Think about it, guys. If I want to find tangential acceleration, I can just use alpha r, right? alpha, I have already figured it out to be 6, radius 2 meters. So I think it should be 12 meters per second square. That is your tangential acceleration. Similarly, if I have to find the centripetal acceleration, I think I can use omega square r formula. Omega, I just found it out to be -1. So -1 square into radius. Radius is basically 2. So it is just going to be 2 meters per second square. So that is your centripetal acceleration. So I think I found out all the answers. Exactly. Very nice. Many of you have found it out with me. Very good. Keep it up. Proud of all of you guys. Very nice. Great. 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 So guys got a very good idea on omega, alpha, tangential, centripetal, so many questions, how to compare them and all of that. Now, let's move to the second part of the chapter. All that we have spoken about is velocity, displacement, angular position, angular displacement, angular acceleration, velocity, all these terms. You know what are they called? They are called as kinematics. The moment you incorporate mass and why it is happening, that is force, it comes under a separate division called as dynamics. That's why the first few chapters, what you learn, velocity, vector addition, relative motion, acceleration, changes in velocity, displacement, position, distance, all these things you learn. And then suddenly in Newton's laws, mass, you talk about inertia, and then you define force, F is equal to ma, and suddenly you have why things are happening. Why is it going that way? Why is it doing this? That is dynamics. MTG is good, but not maybe sufficient, bacha. You should solve PYQs and other things. Let's keep it for a separate day. Now, what we are going to talk about is forces involved in circular motion. Let's take up a simple circle. Let's just take up a simple circle over here. Just imagine, let's say this is the radius, this is the center. The particle has some velocity here like this. This is the velocity of the particle. Okay, it has some acceleration as well. So this is the tangential acceleration. Obviously, this is the centripetal acceleration. What is this? This is the centripetal acceleration. Okay, fair enough. Obviously, they are perpendicular to each other. If there is acceleration and this particle which is going around, it has some mass, obviously there must be some force on it. Without force, it can't accelerate. Somebody is forcing it. Why otherwise will it accelerate? Will you study if you don't have exams? No, right? Will you study if there were no, universities, or there was no profession, there was no career, there were no doctors? Will you study? No, right? Same way, there must be some reason for something to happen. That happening is acceleration. That something which forces, that is the cause, is the force. So, that force which is providing the tangential acceleration, what can I name it? Come on guys, no points only for that. Obviously that should be called tangential force. Obviously, tangential acceleration, tangential force. Similarly, that acceleration which is provided because of a force, that force, because this is centripetal, what is this called? Centripetal force. That's it. So these are the two forces which provide tangential and centripetal accelerations. Now obviously the result of both these accelerations, might be here. That is the total acceleration. The total acceleration will also give rise to the net force. This will also give rise to net force. So here is what I'm going to say. F vector, which is the total force, is the contribution of centripetal force plus the tangential force. Magnitude wise, F is just simply put Fc square plus Ft square. Fc square plus Ft square. As simple as that. These are the two simple things which you should understand. Total force is the composition of centripetal and tangential force. By using Newton's laws of motion, centripetal force will be mass into centripetal acceleration. Obviously, no, centripetal force will be nothing but your mass multiplied by your centripetal acceleration. Similarly, your tangential force will be nothing but your mass multiplied by the tangential acceleration. That's all. That's all. Newton's laws. F is ma, so Ft will be mat, Fc will be mac. That's how you can also find the total force also. In fact, you can also write this one. The total force is also, I can just write, it is the total mass into the total acceleration. That is also okay. Nothing wrong in that. Nothing wrong in that. It's perfectly fine. This force is this mass into this acceleration. This force is this mass into this acceleration. This force is that mass into that acceleration. Is that clear, everyone? Now you might be wondering, okay, fine sir, centripetal force, tangential force, fine. Where are they? In my daily life, what is this centripetal force? Can you show it to me? Can you explain that to me? Yes, definitely. But before that, a disclaimer. A disclaimer. Centripetal and tangential are not new forces. They are not new forces, but the names given to the components or forces that provide the necessary centripetal and tangential acceleration. You might be like confused for a bit. Sir, what is this statement? I'm not able to understand. Hold on. You will understand this statement completely with this example. Just look at this example. Okay? Imagine there is some mass over here, and this mass is going in a curved path like this. And there are many forces acting on it. One of the forces, let's say mg. Okay, maybe mg like this. Maybe somebody is pulling the string, maybe like this. There is tension over here. Okay, just imagine. Maybe there is a spring kind of a force. So there is spring force, let's say kx. Just examples, okay? These are some forces which are acting on this particular system. And maybe even something else is also acting. Maybe there is a little bit of friction also. Maybe there is little bit of friction also. Maybe there is mu into n which is acting, or I will just put it as F. Frictional force. Okay, everyone fine? Now I want to show what are the different forces, centripetal wise, tangential wise, how do I write the equations? That's what I'm going to explain this to you. Obviously, since it is going in a curved path, it might have some centripetal and tangential acceleration. Circular motion, changes direction, changes speed, tangential, centripetal. Okay, so I will just show tangential acceleration maybe like this. Who knows, maybe it is down, maybe it is up. I don't know, I'm just going to assume it. And maybe there is also centripetal. So the circle's center will be here. So that's why I'm just going to show the centripetal acceleration. Everybody cool till this point? Perfect. Now observe how I'm going to write the Newton's laws of equation. Just remember one simple thing. Force is equal to mass multiplied by acceleration. That's all. Force is equal to mass multiplied by acceleration. That's all. Everything will work out. So first take the tangential direction. And let's see what do I get. In the tangent, friction nor spring is there. Tension has a component, let's say I call it theta. So tension's cos theta is there. Mg is opposite to the acceleration. How do you write force, net force? Forces in the direction of acceleration, positive. Opposite to the direction of the acceleration, negative. So you're just going to say tension's cos theta positive because it's in the direction of acceleration. Mg is opposite, so minus mg is equal to mass into tangential acceleration. That's all. If you want further, you can write this as m, and let's say this has some angular acceleration, for example. Then you can also write this as m into alpha into r if needed. Else not needed, no problem. Cool? This is along the tangent. Now along the radius, along the radial direction or the centripetal direction. In this direction, I can see this guy is there, friction is there, and a component of tension is there. opposite the acceleration. All the people supporting acceleration are positive, opposing it are negative. So spring force positive, friction positive, tensions sine theta negative. What are they all doing together? Mass into centripetal acceleration. If you want, you can also write omega square into r or v square by r. It's up to you, or m into v square by r, whatever is given. All of them mean the same thing. Now, doesn't it feel like you're just doing Newton's laws? Doesn't it make you feel that you're just drawing FBD and writing F is equal to ma? Where is circular motion here? Only in this tiny part, tangential acceleration and centripetal acceleration. Then you might be wondering, sir, where is the centripetal force? You have done something wrong, sir. Where is the centripetal force? Why did you not show FC? Okay, you will be like, sir, where is FC and where is FT? Lot of students do this mistake. They show FC and FT, and many schools, coaching also have taught this. Show FC and show FT. Don't do all these things. What did I tell you? Centripetal and tangential is not a force. It's the name given to the forces which provide the necessary centripetal acceleration. So my dear students, writing over here centripetal and tangential is completely wrong. In fact, these people together, that is basically your tangential force. So tensions cos and mg together is tangential force. The centripetal force is spring force plus friction minus t sine theta. That is your centripetal force. Now this centripetal force can be spring also, can be friction also, can be tension also. If weight was at an angle, then even weight, maybe normal, maybe electrostatic, maybe magnetic. It could be anything. It's not a new force. So do not show something as FC or FT. These people only are FC. These people only are FT. So it's not a new force that you show over here, just like you show weight and all these things. Is that now clear in your head? Got it, everyone? Mind blown for the 5th time now? Nobody tells. And I've seen students saying this. I feel very sad for all those students who say, what is the formula for centripetal force? Sir, the formula for centripetal force is m omega square r, mv square r. I'm like, what are you saying, man? Centripetal force formula is not mv square r or m omega square r. It is a name given to things. So centripetal force is t, it could be anything. Like in this case, it is kx plus f minus t sine theta. The value of the centripetal force is omega square r. But it is not m omega square r. Understand the slight difference. The value of the centripetal force is m omega square r, but centripetal force is not m omega square r. How many of you got it? Put up a fire emoji. Centripetal force actually is just this plus this minus this, depending on situation to situation. The value is this, but it is not centripetal force. Lot of people also I have seen doing this stupidity. So please don't do that. They show this mv square by r. I hit my head against the wall when I see students doing this. What nonsense is this? This is not a force, guys. Never show this. Never ever show this. That is illogical. Awesome, awesome, awesome. Great. Now that you understood this, let's take up a good example. Amazing example. Looks like the chat box is all warm. Awesome. Let's take a cool example of a conical pendulum. It is also very, very important from your NEET perspective. We'll slowly go to cars going on a curved road and all those examples, obviously. So let's talk about conical pendulum. When I say conical, conical means like a cone, like the cap that you wear during your birthday. The cap. I'm pretty sure there is an emoji for that as well. Maybe somebody can put it up. So the conical cap is a good example of a cone, and a pendulum means, conical pendulum means the particle is going like this. So if you see the wire or the rope, it goes on the curved surface of the cone, something like this. This is your mass, this is your length, this is your angle theta, perfecto, and it is going in a circular path, maybe like this. Oops. Perfect. This is your center of the circle. All right. Perfect. Great. Awesome. Now this is a conical pendulum. I want to find out what is this angle. I want to find out what is the tension. All these basic things, and many questions will come on conical pendulum also. So first, just draw the FBD. Whenever you see a circular motion problem, draw the FBD and then try to analyze. What could be the forces on this guy? I know one thing is there for sure, tension is there. So I'm just going to show the tension force like this. There is tension force like this. Cool. There is tension over here. There is weight downwards. The weight or mg force is there downwards. That's it. Don't even think of showing centripetal or tangential. That will be stupidity. I just told you. Please don't show mv square by r. Not allowed. Not exist. Next thing I realize is that it is going in a constant speed, with a constant speed over here. So since velocity, its magnitude is constant, basically it is uniform circular motion, uniformly circular motion. So hence, can I not just say that guys, the tangential acceleration doesn't even exist? The only thing which exists is the acceleration towards the center, and that is the centripetal acceleration. You can see it is passing through it. Perfecto. This is also 90 degree. Awesome. Now just split the forces. Now just split the forces into two components. Tension will have one component like this. So there is another component here, and this is theta. These are two parallel lines. So if this is theta, alternate angles, guys, this is also theta. Makes sense. So naturally the one which is closer, closer. So this will be t cos theta component. The one which is far away, sin component. So this will be t sin theta. So I got both the components. Now I'm just going to apply Newton's laws of motion. Newton's laws of motion, nothing else. So first in the y-axis, and then next along the x-axis. So in the y-axis, in the vertical direction, there is no acceleration, but there are two forces. So what will they do? Cancel. Obviously the mass is neither going up nor going down, so they have to balance each other. So t cos theta will be balancing mg. So basically they are balancing each other, cancelling out each other. Cool. Then this force, what does force do? Mass into acceleration. So what is the force? It is nothing but t sine of theta. T sine of theta is equal to mass into centripetal acceleration. But centripetal acceleration, I can say if I know the angular speed, let's say which is omega, then the centripetal acceleration will be omega square into radius. Don't put L. L is not the radius. That's a common mistake. L is not the radius. Okay, what do I do with the radius and all these terms? No worries. Just look at this triangle. This is L, this is theta, this is R. Think and tell me which ratio would you be interested? Cos, sin, tan, opposite, na? So it will be basically sin theta is a radius by L, opposite by hypotenuse. So shouldn't R be equal to L sin theta, my dear students? R should be equal to L sin theta, my dear students. So think about it. If I just substitute, instead of R, I just put L's sin theta value. L's sin theta value, what am I going to get? M omega square. M omega square, and here I have t sin theta. The best part is sin theta cancels, sin theta cancels, and I am just left with t is equal to m omega square L. Perfecto. I got the tension which is unknown. Amazing, right? Loved this, guys? Loved this derivation? Okay, so this is how you can find tension. And if you put the value of tension here, you will also get the value of cos theta if you want. Okay, so if you want, you can also solve this for cos theta. So instead of tension, you put m omega square L into cos theta will be nothing but m into g. You can see that this mass and this mass done cancels, and I'm just left with cos theta is g divided by omega square L. This is another formula which you can remember to find how much angle does this pendulum make with the vertical. Great. Amazing. Amazing. This is the best example of how you can use Newton's laws and how you can also use the concepts of circular motion. Great. Amazing. Let's move ahead. Let's also talk about uniform circular motion since we have come to it. What do I mean by uniform circular motion? What is your understanding, guys, for uniform circular motion? Just put it up in the chat box. You might be wondering, sir, usually we teach uniform circular motion first. You are teaching somewhere in between. That's the whole idea of me teaching here in a very different way, so that now you will never forget, guys. This is the radius. Okay. This has some velocity. Okay. It also has some angular velocity and maybe some centripetal acceleration as well. Yep, constant velocity, that's a wrong word, guys. So in case of uniform circular motion, what happens is speed is constant. Speed is constant. Velocity is changing. Velocity is changing what? Direction, not the magnitude, only the direction. The direction only. Yes. So because the velocity is only changing the direction, not the magnitude, can I not easily say that, okay, maybe I'll just put it over here only, that the tangential acceleration is 0, but the centripetal acceleration will be v square by r, or you can also use omega square r. One and the same thing, v square by r or omega square r. Perfect. Also, I can say that since tangential acceleration is 0, even alpha is 0. But omega is going to be just v by r, which is going to be a constant. The angular speed is going to be a constant. It will not change. Equal angles, equal time. Equal angles, equal time. 10 degrees in 1 second, 10 degrees in 1 second, 10 degrees in 1 second. Constant speed. But angular acceleration, no acceleration. It is not changing its speed. It's only changing the direction of the velocity. That's all. Cool. Now there is one interesting thing which you should know about uniform circular motion. And that is basically the time period. These are new terms that you might be seeing. Time period T. Basically nothing but the time taken for one revolution. What is it? Time taken for one complete revolution. One complete revolution, guys. So now, if I ask you what is the time period, you will be like, wait a minute. Time is total distance. Time is total distance by what? Speed, right? Achha, what is the total distance? It is circumference. It is nothing but circumference divided by the speed. What is the circumference? It is 2 pi r. What is the speed? V. Hold on. R by V, what will it be, guys? What if V by R is omega? What will be R by V? What will be R by V? Think about it. 1 by omega. Can I not just put this as 2 pi divided by omega? Just look at this. V by R is omega. So if you want, I'll use the same symbols, capital R. Okay, great. So this is nothing but time period is 2 pi by omega. Beautiful, beautiful formula. Very important. You can also, if you don't want to look at it like this, you can also take omega here, time period below. Also, you can say that your omega is 2 pi by time period. One and the same thing. One and the same thing. Okay. Very important another term, guys, and that is frequency. Frequency. Just like you have time period over here, one term, there is another term called as frequency. Symbol for that is F. It is nothing but number of revolutions per unit time. Per unit time. That is frequency. The formula for that is 1 by time period. Usually the units is hertz. Formula is 1 by time period. That's it. So how many revolutions I complete in one unit time? That is what is frequency. If you notice 1 by t is here, 1 by t is also here. So instead of writing it like this, you can also write it as 2 pi into frequency. It means the exact same thing. There is no difference. 2 pi by t also, or 2 pi f. one and the same thing. Is that clear, my dear students? All these are important formulas and concepts related to just uniform circular motion. Time period, how much time it takes to complete one revolution. Frequency, 1 by time period, how many revolutions you do in 1 second. Omega is 2 pi by t or 2 pi f, one and the same thing. Yep. There is no tangential acceleration, there is no angular acceleration. Centripetal and omega both are there. All concepts on one slide. So guys, all of you are going to get these notes, don't worry. Let's do a simple question on this. A wheel has RPM, rounds per minute. Okay, let's say I just give it as 120 rounds per minute. Okay, and radius of, imagine, I don't know, I just take 2 meters. Find time period, frequency, omega, linear velocity of the point on the rim. All these things I have to find. Let's try this out. Okay, simple uniform circular motion problem. So it is clearly mentioned 120 rounds per minute, meaning I'll just write it over here. This just means 120 revolutions in 1 minute. 1 minute has how many seconds? I'll try to convert everything into seconds, SI units. 1 minute is nothing but 60 seconds. So if it does 120 rounds in 60 seconds, in 1 second how many rounds will it do? Therefore, how many revolutions or rounds will it do in 1 second? Put up the answer, guys. Put up the answer, guys. How many rounds will it do? Come on, I want everybody answering it in the chat box. Obviously, it will do 2 rounds or 2 revolutions in 1 second. Perfect. 60 seconds, 120. So in 1 second, 120 by 60, which is 2 rounds in 1 second. Perfect. So if it is doing 2 revolutions in 1 second, that means per unit time 2 rounds, that is the frequency. So the frequency is 2 hertz, as simple as that. That is the first answer that we got. The first answer that we got. Perfect. Now once I know the frequency, I can also find the time period. Time period is nothing but 2 pi. Oh, sorry. Time period I can just use 1 by f. That's all. So 1 by f. So this will be 1 by 2. So time period is nothing but 0.5 seconds. It takes just a half second to complete 1 revolution. Because it completes 2 revolutions in 1 second, it takes half a second to complete 1 revolution. Next is omega, angular frequency. Angular speed, sorry. Angular speed, I can use 2 pi f or 2 pi by t, whichever you want. So let's say I use 2 pi f, it will be 2 pi multiplied by 2. So it will be 4 pi radians it is covering in 1 second. Think about it, what it means. 4 pi radians. Guys, pi radians is 180. 2 pi radians is 1 revolution. 4 pi is 2 revolutions in 1 second. That's all. So when I say angular speed is in radians per second, that's what it means. 1 revolution is 2 pi, 2 revolutions is 4 pi. So that's what it says. Lastly, what is the speed of that particle, guys? So speed is r into omega. What is the radius? 2. What is omega? 4 pi. So it will be 8 pi, but this will be meters per second. You can put the value of pi if needed to find the answers in decimals. Otherwise, you can leave it like that. Great, Anish. Awesome. Navya, very good. Okay? All right. Great. Amazing. Monu, I'll come there, bacha. Please don't cry. I will come there. Definitely from tomorrow. All right. Oh my God. Why is this coming like this? Hold on. I just need to create more slides over here. Blank slides. Just 1 second. Okay. Next concept. Let's go to car going on a banked road. Car going on a banked road. What's your favorite car model, guys? Which company is your favorite car? Please tell me. I'll draw that car. If you tell me quickly, I'll draw it quickly, or else I'll start drawing. Have you written down something? Tesla. Oh my god. Apple company car didn't come out also. Tesla. How to draw Tesla, yeah? It's crazy, man. I don't know how to draw Tesla. I should put some T over here, maybe like this. Okay. Does it look like a Tesla car? I'll also draw the lights. How do the lights of a Tesla Model S look like? Like this. And also beautiful indicators maybe. Okay, great. So this is our road. Cool. That's enough. Okay. Great. Cool. So let's try to understand when this car is going on this curved track with some velocity v. Okay. With what maximum speed it can go so that it doesn't slip. To understand this problem, let's start with the free body diagram. What kind of forces are there on this car when it is going? One thing is obvious, it's the weight of the car, so I'm just going to write mg over here. It's on the ground surface, so it is going to provide a normal, so I will also show a normal force on it. Because it is going with a constant speed, I don't think there is any need of tangential acceleration. So tangential acceleration is 0. There is no force in the or against the direction of the velocity. Nothing along the tangent. But centripetal, definitely there. There is going to be some kind of acceleration towards the center. I also know that there is some radius involved over here. This will be the center of the curvature of the road. There will be also radius of curvature as well. This is your center, this is your radius. Perfect. Now there is one more force remaining. Sampath has said it. Yes, friction. Where do you think I should show friction? Up, down, left, right, in, out. Where do you think I should show friction? Kritna, Leishram, never ever show centripetal force. Remember that? Centripetal force is not a force. I just explained that, right? So take it out of your head. Sampath, remember, centripetal force is not a force. Remove it out of your head. Very good, Isake. Friction should be there. Rolling friction, ignore that. For now, we are not taking any forces in the tangential direction because this is 0. Else tangential friction, rolling friction would have mattered. Cool? Acha. So where should I show friction? Think normally. Guys, centripetal acceleration is there towards the center. Who is giving that? Who is causing that acceleration? Is normal causing it? No, it's perpendicular. Is weight causing it? No, it's again perpendicular. There's only one force then. That is friction. Yes, Isage, the friction is acting like the centripetal force. So centripetal force is not shown separate. You just show on the tires of the car, there is a separate frictional force that is providing the acceleration and behaving like the centripetal force. No separate centripetal force is there. So my dear students, here is what I'm going to write using Newton's laws. So force is equal to mass into acceleration. Acceleration is nothing but v square divided by r. So that is going to be your friction. Everyone with me? Awesome. Now my question to you is this. What would happen if I increase speed? Come on, think about it. Will friction increase or decrease? Slowly I press the accelerator, I go to a new speed. Press the accelerator, new speed. So if I increase my speed, what will happen to this friction? What will happen to this friction? Think about it. Obviously friction will also increase. But friction can't increase indefinitely, no? There is a problem with that. What is the problem? Beyond a point, it reaches limiting value. And after that, it begins to slide. So this is good as long as it is static. But the moment it reaches the maximum static limiting force, so it becomes Fs max, then this speed will be the maximum speed with which it can go on the curved track. So this is on the verge of the slipping. This is on the verge of slip. It has not yet slipped. Anything more than this is going to slip. What's Fs max, you might say? Fs max is nothing but, simply put, Fs max is nothing but mu into n. So it is mu into the normal force is equal to mv max square divided by r. Notice over here normal force and mg are balancing each other. So I'm just going to put this as mu mg is equal to mv max square divided by r. So can't you see, my dear students, mass and mass got cancelled. Mass and mass got cancelled. Bring r over here. So it will become mu gr is equal to v max whole square. take root on both sides, flip it. So you will get V max is equal to root mu r g. That is my final formula that I wanted. Maximum speed. Anything more than this, you are going to slip. Anything more than this, it's going to slip. That's it. So I found that speed. If I want not to slip, I'll make sure my speeds are lesser than this. It depends on the coefficient of friction, the radius of the track, and acceleration due to gravity. But now I'm not satisfied. I get this speed. Imagine you get this speed for some reason 60 kilometers per hour. I will not be happy only. I'll be like, what nonsense. I can't go on the curve more than 60. But I want to go at 70. I want to go at 90. I want to drive my car very fast. I want a Tesla car, man. Look at this. This is a Tesla car. And I'm not going to drive it at 60 kilometers per hour. I'm very angry. I write a letter to the government. Government thinks they hire their engineers and they are like, hey, listen, you can increase the speed. How? Bend the road. Bank the road. You will increase the speed without slipping. So that is basically the next concept of, the concept of banked roads. Let me just write it over here. Banked roads. Banked roads. So in case of banked roads, you will notice you tilt the road by an angle. You tilt the road by an angle. This is your vehicle. This is your vehicle. And it is going like this with some velocity. In this case, what happens is, because you have tilted, you will notice the centripetal acceleration is not just provided by friction, unlike here, but because you tilted it, there is a component of normal. There is a component of normal force. You can see normal has a component which helps in the acceleration. It is supporting the friction. Unlike here, normal was not helping only. But the moment you tilt, the normal comes in the direction of the acceleration slightly, a part of it, which helps in the acceleration. It reduces the burden. It reduces the burden on the friction or the dependency on the friction. That's when it becomes more reliable and you are able to accelerate further and increase your speeds without slipping. So other forces remain the same, which is like weight, and your friction will act downwards. The friction will act downwards, and then when you write all the equations and all that stuff, you will get the answer. There is nothing great about it. So the final maximum speed with which you can go turns out to be root of radius times acceleration due to gravity, coefficient of friction plus tan theta upon 1 minus mu tan theta. This is the maximum speed with which you can go, my dear students. Anything more than this is bad, but this is higher than this speed. This is maximum speed, but not so great. Maybe 60 or 70 kilometers per hour. This will be maybe 120, 150 kilometers per hour. This is more than the previous one. So you will feel better while driving the car. But guess what? There is this friction, right, which was acting. That friction is always a bad thing. It will cause wear and tear of the car. What does it cause? Wear and tear of the car. You do not want that. What do? You remove the friction. So to remove friction, when you remove friction, basically reduce the wear and tear of the tires of the car. You will see if friction is removed, mu will go away. If mu is 0, come on, think about it, mu is 0. This will just become 1. This will become 0 plus tan theta, which is tan theta. That will become just root of rg tan theta. Such a speed is called as optimum speed. This is the optimum speed with which if you drive, little wear and tear, hardly any friction, and you can preserve the tires for a longer duration. This is usually the speed which is recommended unless you want to cause some skidding or not skidding, basically wear and tear of the tires. Is that clear, my dear students? Everyone with me? So you have learned a lot of stuff now. You have learned how to apply your Newton's laws with circular motion in case of special applications like a car going on a curved track or on a banked road. Great. There is one last thing which I would like to tell you. And for that, let me remind you of the childhood memories maybe. What is this, guys? Hello, bright sun. Welcome, bacha, new members. What is this, guys? Have you done this? What is it? What is Pandu doing? What is Pandu doing? He's on a merry-go-round. He's rotating. And you would have experienced this in a park or maybe in your school, that when you go and rotate on your merry-go-round, yes, you will feel as if somebody is throwing you out. Nobody is actually throwing you out, but you feel like that. Okay, let's look at it from the top view. Let's look at it from the top view. If you look at it from the top view, this is the merry-go-round. You will see the Pandu's head. This is Pandu's hair. Okay, you will feel as if this guy is experiencing some kind of force. It's not a real force. The moment the force is not a real force, it is called as a pseudo force. It is called as a pseudo force. This person on the merry-go-round feels it, but if there was another Pandu standing here, he will not experience it. So this rotating frame, my dear students, this rotating frame makes you believe that there is somebody pushing you. That means this rotating frame is definitely a non-inertial frame. What is it? A non-inertial. And in non-inertial frames, just like you have seen in Newton's laws, there is a pseudo force. Here also there is a pseudo force. This pseudo force is just called as a centrifugal force. Centrifugal. Guys, this is opposite to centripetal and it is only there in non-inertial frames. Please mind this. It's only there in non-inertial frames, and this is called as a pseudo force, which is the centrifugal force. The value of this centrifugal force is simply put the mass of the object into angular speed square into radius, or you can also use mv square by r, that's okay. This is the value of the centrifugal force that you experience. This force only show it in a rotating frame. If you are outside, then you will not show any centrifugal force. Think about it. If you look at Pandu is holding his hands like this. So can you think there is also a force of tension or normal on Pandu's hands which is pulling him inside? There will be a force because of this rod which is there at the center. It is pulling Pandu towards the center. So won't that force balance the pseudo force, centrifugal force? They both are cancelling each other. That's why Pandu is neither going here nor going there. Both the forces are balancing each other perfectly. Okay, so that's how you should look at centrifugal force. So in today's session, basically what we have done is completed the main aspects of circular motion, be it uniform circular motion or non-uniform circular motion. We have discussed all the parameters right from position, displacement, velocity, angular acceleration, tangential acceleration, centripetal force, centrifugal force, tangential force. We have discussed all these things. We will implement all these things in problems in the next session. Okay, so make sure you join the Telegram channel. Link is there in the description box. Download the entire PDF. You can add it to your notes, make your notes. And if you want more things, you obviously have the crash courses right for you with assignments and all the modules and all the teaching materials and the test papers and everything that you need. Okay, I hope you guys enjoyed the session. Make sure after the session is over, you have watched it and you have enjoyed it, make sure you not only like and also subscribe, but also recommend this channel to all your friends. And do one more thing, guys. Just let me know that you have watched this video in the chat box. Even if you are not live, even if you are recorded, fine, I'll at least know, okay, yes, so many students watched it, you have done this chapter, and what's next? Problem solving. And I'm going to come up with a very special session for all of you in the next few days, okay? That's it from my side. We'll be doing problem solving, like I said, Amargiri Manoj, in the days to come. Yep, I will do current electricity also very soon. Yep. Let's just complete few more high weightage topics of 11th. 2-3 more high weightage topics, and then we'll go to 12th standard topics. I know you guys are all excited for boards and all of that. I'll come to that. Okay, that's it from my side, guys. Bye bye. Have a great time. Have a lovely evening. See you. Sleep well. Have a great time with your family and great time at school as well. Bye bye. See you. Hasta la vista.